Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Patrick Lewis to the Weaviate Podcast. Patrick Lewis is, I would like to say, the inventor of RAG. That's something we'll talk about in a second. He's the lead author of the original Retrieval-Augmented Generation paper. And Patrick has done so much amazing work in the space of natural language processing broadly, I want to say, because the coverage of all your papers is just so extensive, from DPR to RAG to KILT, and then even task-aware retrieval with instructions. There's just so many exciting ideas. Patrick, thank you so much for joining the Weaviate Podcast.
Thank you very much for having me. Yeah, I'm excited to be here.
Awesome. So could we dive into this kind of like origin of retrieval-augmented generation? I know it goes back as early as like 2019 that you've been thinking about this.
Yeah. So I think, thank you very much for the intro, saying inventor of RAG. I think I'll backpedal a bit. Like the kind of idea of getting computers to speak to corpora of text is super old. And it goes back to like almost as old as kind of computers. So there's kind of some evidence of it from the 60s, and you kind of have like question answering systems, and people kind of working on these systems that have the kind of DNA of a model or some kind of computer program, trying to access information that's stored in an index or a database, and then use that to achieve a kind of task or a goal. And usually it's framed around question answering, and that's changed pretty recently, actually. There's been other uses for this over time, but until very recently, the really, really big dominant way that you'd study this is in question answering. And it goes back really, really far, and the kind of continuous levels of improvement. There are even in terms of the intent behind systems, there are like kind of question answering systems from the 90s. Like AskJeeves was kind of the intent behind AskJeeves was to try and answer your question and not find you a document so you can find your own answer. And then if you look at the architecture of some aspects of how the original IBM Watson, the Jeopardy model worked, it had similar kind of conceptual underpinnings to this. And then throughout the kind of 2000s and 2010s, particularly the 2010s when neural models came along, the kind of one conceptual shift is like, okay, you can move from having models that kind of pull out and heuristically extract information from text for your use case to having a model that kind of reads it in a more connectionist kind of way. Those kind of came along. A bunch of folks kind of looking at these machine readers initially, these machine comprehension, machine reading models, and then people hooked them up to retrieval databases, and you had this kind of first big kind of conceptual open domain QA models, I guess they were kind of referred to. And then it kind of accelerates from there, I guess. Lots of people excited by bigger models, neural models that kind of had their own had sort of a much stronger kind of capability, and really interesting ways that you can kind of train these things end to end. So all of these things were going on and have been going on throughout the 2010s and before. There's also connections to some kind of parts of semantic parsing, especially end to end, has some kind of similarities. Long story short, lots of people publishing lots of stuff. Over the kind of late 2010s and 2020s, a bunch of people kind of realized you could train a neural dense embedding retrieval model and a neural reader and get these really compelling kind of systems, and you could maybe distantly supervise those things. I guess the RAG paper is a weird one because it's sort of very much along that kind of line of the zeitgeist. It just was there at the right time to kind of knock away a little bit of the conceptual blocker that you could have a generative model that did this. So like a seek-to-seek model, input sequences, output sequences, and retrieve in the middle, and just was sort of there at the right time, the right kind of messaging. And it seems to have captured the kind of imagination of people. But I'm always very careful to try and credit, the continuous process of innovation, which is like thousands of people over many, many decades.
Yeah, well, I think in addition to the paper, you also did this lecture. I think you were in your PhD at UCL, and this lecture really explained it. Because I think that I think you nailed it with that connectionist perspective. I don't think a lot of people were thinking that you could separate, retrieve, and then read. And so it was just like a really elegant way of forming it. And so kind of the next question I want to ask you about, so people have running away with RAG because we can just kind of plug in these like language models that have been trained for something else. We can just kind of like append RAG onto them, right? And so I thought this paper Atlas that you published was so profound, where how it shows that with 11 billion parameters, you can still do this kind of like reasoning capability with the retrieval augmentation. So I think if you don't mind talking more about Atlas, because I think that shows that this kind of RAG has this kind of like economic potential.
Yeah, sure. So in my mind, like, yeah, the Atlas paper came together with a bunch of people at sort of the right time, like people in London that I was working with in the FAIR office. We'd been looking at knowledge and language models, and then Dao, Cohere, and Ethan, the student he was working with, were really excited by this paper called Realm that came out, and then we sort of applied the combination of our ideas to make that first RAG paper happen. But it was quite naive. We kind of stuck it together. It worked. And then we're like, hey, here we go. This is cool. Let's publish this. And then published it. I got bored, like I often do, and then did some other things for a little bit. And then working together with a colleague from FAIR in Paris called Gauthier Issachar and his supervisor, Edouard Grave, they'd come up with this really compelling way of using a different kind of architecture for reading with models called Fusion In-Decoder, or FID. And they got really, really good empirical results. And Atlas was effectively our revisiting of the RAG ideas about 2 years or a year and a half, maybe, I think about 2 years later, applying the really impressive, powerful FID model, plus other kind of like stronger dense retrieval models, particularly Contriva, which was unsupervised, another thing that Gauthier and Edouard had done, and kind of combined those ideas together. So like the really, really strong empirical results that came from the new models, and the same kind of spirit of what RAG was trying to do, which is this end-to-end learning. The thing we didn't crack in RAG was how to pre-train these models. And actually that design space is massive, really, really, really big. And the reason you kind of want to potentially pre-train a retrieval-augmented model comes around the ideas of few-shotting and zero-shotting and instruction following and this sort of thing. Otherwise, if you have a bunch of training data and you have a well-defined task, you might as well just, fine-tune the thing end-to-end in a supervised way, and then that's great. But if you have very, very little data, you don't have enough of your kind of data budget to spend doing that fine-tuning. So we were very interested in how to get these, not only, apply the updates and the improvements in models to the paradigm of retrieval augmented generator models, but also to see how well they could work in few-shotting and even zero-shotting situations, how you can design them so that they do work well there, and how that compares to your kind of now relatively standard run-of-the-mill large language model, which is bigger, but just without this retrieval augmentation. So that was kind of what we were doing in that paper, was really kind of trying to deeply understand that design space, how to pre-train these things, how to do so without any supervision, and really ablate that super, super carefully. We were trying to, in some ways, kind of take inspiration from the T5 paper, which again was this kind of like, hey, here's this paradigm, here's the million ways you could do it, and making a fair stab at kind of doing as many of those million ways as you can. And it's not, our paper isn't quite as big or as profound as the T5 paper there, but like there are a lot of tables there that kind of assess all these different ways in which you can hook up a dense unsupervised retrieval system with this powerful fusion in decoder architecture, and how you can get them to kind of mesh together with pre-training objectives over lots of text, and how far that gets you, and to what extent knowledge can be decoupled from reasoning, and the kind of sample efficiency and the kind of, I don't like the term, but scaling laws kind of work for this kind of system as well.
Yeah, amazing. So that T5 paper where they were like, span BERT, mask at the end, and then it's like, okay, well now what masking probability? Just so many different things, right? And that kind of isolation of that. So I have kind of two things I really want to get your take on, which is the fusion into two things of the importance of, which is the importance of fusion in decoder, because right now I think we're mostly just putting it in the input window and then hoping that works, and then maybe if we do them one at a time. I don't mean to get into it one. Yeah.
Let's hit fusion in decoder. So fusion in decoder has a number of like really useful things for retrieval augmentation in general. So it has this really nice property. So it has a few nice properties. One is that like it saves a lot of memory over simply concatenating a bunch of documents together in the input to a model. You avoid some of the worst of the quadratic complexity of transformers. And in a way, you can kind of view fusion in decoder as a type of efficient attention mechanism. You could draw a attention sparse map, and it would correspond to fusion in decoder pretty much. So it saves memory in one way. In other ways, it's useful because you get this document invariance, document positional invariance. So all of the documents are viewed by the model as equal, and you don't get any kind of biases that come through there. And so that's a kind of nice intuitive way of like, here are the set of documents, observe them all. There's this nice deep cross attention between the query and the documents, and that lets the very deep contextualization of the two. This bidirectional encoding of the cross encoding of the documents and queries is probably fairly important, and you don't necessarily get that bidirectionality if you throw it into like a big linear kind of transformer. And yeah, it's great as long as your output sequence isn't very long, and it works well with pre-trained seek-to-seek models. My view now is subtly different. These are mainly kind of practical arguments, but it's still a very good architecture. Where I'm working now, we're not using it, mainly because of the invention of flash attention. So flash attention and other kinds of like additional kind of model hacks have basically meant that it is no longer it's no longer terrible news to have a long context window from a memory perspective. It is a bit from maybe from a performance perspective, maybe from a latency perspective, it's kind of worse. But it's no longer prohibitive to just like have a really long sequence. And the other thing is that big standard large language models, left to right, GPT, like a la GPT, like everyone's got one now, Llama, etc. There's so much R&D and so much ablation and so much care going into those, and all of the kind of tooling that goes in there, and especially in the open source, it's very hard to bet against that model being better, maybe not because it's inherently better, but because people have worked very hard to make it as good as it can be. And there's a smaller brains trust working on seek-to-seek models and fusion in decoder, et cetera, et cetera. There's this whole space, like a really exciting design space of models that are somewhere in between, depending on how you kind of draw a sparse attention map. So there's some really interesting research that I poked for a little bit along with an intern called Avi and Edouard before I left FAIR that was looking at that, and Gautier as well, which is really exciting. We didn't quite manage to make it work, but like I think there's still a lot of interesting things in the space of how to process documents along with a input and produce an output in an efficient way with the right kind of attention, etc., for language models. But yeah, from a practical perspective, at the moment, I would say if you want results, fork out for a long context model and just use a large language model. Yeah.
Yeah, that's fascinating. I guess I always thought there was something to like putting the embeddings in the middle of the transformer, like in layer 8 out of 12 or whatever, compared to just putting it in the input. But I guess you still embed it in the input. So that argument's gone. And flash attention. And we had Ophir Press on the podcast to talk about alibi attention. So a little bit of, we've been looking into this positional embeddings and how that works.
Yeah.
And maybe just one other nugget that I took out of what you're saying is there's that Lost in the Middle paper that's talking about maybe, and so Lost in the Middle is saying like if the right information is in result 5 out of 10, then it can't attend to it.
Absolutely, yeah. So Fusion In-Decoder does not have that problem. It's actually invariant to that. So like the result is mathematically identical. It doesn't matter where you put it in. There is not that concept of ordering, which is really nice. That is a great thing about Fusion In-Decoder. I would say maybe that is an observation-based paper. I'm sure I don't look at the literature nearly as much as I used to or as much as I should. But I believe there are ways to combat that empirically. Some I'm aware of, where you don't see that kind of problem happening. So the retrieval-augmented models that I'm training at Cohere right now, for example, are almost invariant to document position, and they are based on standard model. And you kind of have to just prepare your training data in a very careful way. But yeah, like I think that's a bias that kind of comes through mainly from the combination of ways these models tend to be trained, whereby the beginning of general documents that you might need to, complete the end of, the beginning is important and the last few words are important, and in the middle just naturally is less conditionally important. But if you then fine tune the model to make the middle more interesting, then you can kind of recover from that a bit. But it is nice to have, inductive biases that mean you don't have to worry about that. So that's why those kind of Fusion In-Decoder models can be really good for that. There's also like other ways where you can make them very, very, very fast. One of the people I work with at Cohere now, Sebastian Hofstadter, has a really interesting paper from, I guess it was a year and a bit ago now, called FID-Lite, of basically working on kind of slight changes to FID that make it really fast and very productionizable. And that's very cool. Like that kind of a thing is really interesting. Yeah.
Yeah, amazing. So we're about 15 minutes in the podcast, and I've already gotten a massive takeaway just in that insight, and I have so many other topics to get into. But I think that's so interesting. But so the next topic I really want to get your take on is RAG end to end, putting the gradients from the reader back into the embedding model, and how you're currently seeing that.
Yeah, so there's many different ways you can do it. The original RAG paper was using pretty much like initially taking inspiration from a paper called Realm, which came out kind of as we sort of started this project, but not really got into the stride of it yet. And they had some like very like simple, straightforward marginalization based ways of kind of training a model end-to-end / jointly, kind of depending on how you look at it. But yeah, kind of this nice little probabilistic model with a slight kind of fudge for a top K truncation as opposed to a proper marginalization. And that's really nice. And it works very well for the span-based method. But so the first thing we did was say, okay, like we can train a model like this with a generation model very easily, but it's quite slow to decode from. So we thought of like other ways that we could do it. Effectively, you kind of have a model that generates a long list of words, and you sort of need to marginalize across every single time step. And that's really, really slow. So we're like, okay, let's not do that. Let's fudge, fix the documents every time. And that's where you get one of the formulations from the original RAG paper. The other thing you can do, so that's kind of called RAG token, I think it is, where you're kind of pretending to do that marginalization at every token step, but you're keeping the documents fixed. You're not doing a retrieval every token, but you could do. And then there's the second one called RAG sequence, where you do like one marginalization over the sequence. and that's much harder to run inference on. So those are the kind of things that we started out with, and then I think driven really by like my colleague Cohere and Edouard together, they kind of came up with other ways of doing this that kind of were a little less maybe like theoretically kind of off the shelf, but much more flexible. These kind of distillation style approaches where you kind of say, all right, I want to train the generation model. How do I do that? Well, I just need some documents that come from a retrieval system. As long as they're not total garbage, you'll learn something useful from them. And so, okay, you need a retrieval system that gets you some documents. You use that plus the input to try and train the model to produce your target output. That's fine. And then you need a way to train the retrieval system. And they basically say, okay, well, let's try and distill out some relevant signals from the language model part of the system. And that's the high level kind of thing they're saying. We know the language model is capable of giving us some indication of which documents it likes, and we should incentivize the retriever to rank those ones it likes higher. And there's a lot of different formulations you can do there. And there's some really nice work. I can't remember his name off the top of my head. It's probably bad about it, but really nice work from someone. I'll have to look it up afterwards. Who basically like wrote some nice like theoretical work, produced a new model he was working at DeepMind on an internship, and showed that they're actually quite similar. And there's some math you can do to say that actually those things are more similar than it might seem. But yeah, effectively now I'd say the recipe is something like have a language model that conditions quite strongly on documents, use that to obtain signals with which to fine-tune a retriever, and then iterate between the two. You can also write like interesting EM-style algorithms to do the same sort of thing, but usually it kind of comes down to hacking something together that kind of iterates between, I'm going to train the retriever for a bit with relevant signals from the generator, and then I'm going to pull out lots of stuff from the retriever and train the generator, and you kind of go in that loop. And so from this perspective, you're no longer really training it end to end. I prefer to think of it as jointly. So you're kind of training these two things at the same time, but and that's kind of nice because in some ways then you can almost train them in isolated processes, and you don't have to maintain this one gradient flow through two models, which can be pretty helpful from an engineering perspective.
Yeah, that definitely makes a lot of sense to me that, not putting the gradient from the reader directly into the embedding would be easier if you kind of have the signal from the language model, then contrastive learning with the embedding model. And so really quickly, I have one more question I want to talk about DPR as well and the kind of separate training of the question encoder with the passage encoder. But really quick on this topic, so for me, what makes end-to-end RAG so exciting is the idea of just like one API that does it all for me, right? I don't have to, like where would you say maybe Cohere is at with like, kind of like I fine-tune a language model and I get an embedding model as well?
Yeah, that's interesting. I'd say, so we're not, in my team, we're not directly working on this, but there are plans afoot. We're actually almost in our team doing the opposite in a way. We're trying to get a Retrieval-Augmented Generation API where you hook up your retrieval system in the middle, and we try and work with whatever you've got. So we want to be robust to maybe weaker retrieval systems or term-based things. And what we're doing under the hood there is using re-rankers. So we're trying to basically be fault tolerant. We're trying to also get the language model used to what to do in situations where retrieval has failed. We're also thinking about query reformulation and other kind of like active styles of multi-hop retrieval. These things aren't available yet, but that's kind of what we're working towards, is something that will work with whatever you give it, because often like what people really want is to say, I have this retrieval system, it's been there forever, I can't be bothered to like wrap it or rebuild it. Bad news for Weaviate, but and they want to kind of make it work, and then eventually you can upsell a really nice dense vector database. Like that's what I spend a lot of my our time kind of thinking about is working with what you come with. But like when it comes to those relevant signals that come from a language model and that say of okay, if you know what your system is supposed to do and you have a database of stuff, if you have a database of stuff, I actually, it is interesting to see whether some direct annotated contrastive training with hard negatives and the kind of older style of supervised stuff will work empirically better than trying to get a language model to give you those relevant signals. I think it really depends on how hard you want to solve your task, and how much and what I mean by that is you obviously want to solve your task, otherwise you wouldn't bother. But is this a task that you can anticipate before? How long do you have to prepare? And can you annotate? And do you have the operational capacity to annotate a lot with high quality, et cetera, et cetera? Usually, supervising something in domain is going to work best. And so for really, really intense use cases that you kind of business critical for you and your kind of table stakes, often the best thing to do is just directly supervise on that over the top of some pretty good unsupervised retrieval system. But if that use case kind of materializes on the fly, then you can't do that, and maybe you can use your data more efficiently, or you don't have the ability to annotate the middle bit of put document pairs or document output pairs. Then these kind of end-to-end systems can be a very good kind of option.
Yeah, it's super interesting, and that also kind of answers the question I had on DPR. So I think it would be excellent to kind of transition the topics from here into so kind of mentioning this kind of fitting RAG onto your database systems. I find this one topic of an SQL or a search engine kind of router to be extremely interesting, where you're either you ask the question, what's the average age of country music singers? And so you retrieve with an SQL query instead of vector search.
Yeah.
How do you think about that kind of retrieval tool use?
Yeah, I think that's really compelling for the flexibility. So that's actually what we do right now in our team. We follow that kind of paradigm. So if you use Cohere's Retrieval-Augmented API, you'll find it kind of comes in two halves. And you can hook it up so it goes end to end. But really, there's two calls to a language model going on there. One which figures out what the search queries should be, and soon more general tool API use should be, and the other one which consumes the output of those things. And they're just two large language model calls rather than a kind of dense retrieval call and a large language model call. So we've kind of swapped out that one style of thing for another. That's not to say that you don't need good retrieval systems and the dense retrieval system is dead. That still needs to be there. And, because sometimes you'll call a search engine, sometimes you'll call SQL. But kind of figuring out what to search is really important, especially as you try and, you give higher level commands. I might say, give me the pros and cons about buying a house at this time of year in the UK in this economic climate. That's not something I can produce a query vector to get documents for. And so I really like those things for you. The flexibility is really important. You can write pretty much arbitrary kind of lists of queries to do. You can also make some kind of higher level planning, and transitioning more to this kind of style of agents, I feel is the way things are going, just because it's just very, very compelling. But dense vector search has a part to play within there. You could also take a step back and say, well, I want a model that can be trained end to end in order to generate tool use calls. And that's a black box, and that could be a retrieval augmented model internally. That's pulling up a database of text, of documentation, all kinds of stuff. Like it could be the docs for how to use all the tools, and that's too much in the context window or something. So like you have these kind of black boxes and like kind of where you draw the boundaries around them mean that they're like all kinds of things are possible. But yeah, I would say, you know, having models that aren't constrained to generate one query vector or one query vector followed by another, but can do a very wide, broad output of space of things is pretty important. The other thing to mention there is that if you kind of think a little bit about how, well, I was describing about how you train this style of like how we do it in Atlas, where you're training this 2 hops of a model. Effectively, you're pulling out documents from the retrieval system and you're putting that through the language model. You're producing an output and you're saying, how good is that? And you're training the models with that signal. That begins to look a great deal like good old RL with a 2-hop kind of episode. So it's in an environment, has the ability, it has sort of 2 models that need to collaborate. So it's almost like multi-agent RL in a way, like collaborative RL. And that is a really interesting way to kind of view what these tool use or LangChain, chains of language model inference is doing. Is exactly the same thing. You have a chain of models and together they are responsible for producing a good output or not. So you can kind of think of it like a model or a large amount of parameters that performs a few actions, a few hops, and gets a signal at the end, how well it did. And RL kind of formulations feel like a very natural way of like actually how we should be training these things going forward. And it's still end-to-end in a sense, or jointly trained in a sense, is that you have these 2 and they are together collaborating to achieve this goal. But a little bit less of this kind of like backprop through both models.
Yeah, well, I've never thought of comparing a LangChain chain or like agent selecting tools as that kind of like next state action reward kind of transition reinforcement learning, and that sounds incredibly compelling. And it does sound a little difficult to maintain, maybe, but so I know that you kind of already started touching on this, but I really wanted to also get your thought. I know it's like multi-hop, but I think multi-hop is almost like overloaded, whether you mean like choosing tools or you mean like breaking a question into multiple questions. I know you have this really amazing paper called ConcurrentQA, which is about public and private information retrieval. I think that topic is just so powerful for like our interest at Weaviate as well, because we're curious about like you have your private search database as well as like Google. Maybe just, if you don't mind, just continuing on this kind of multi-hop perspective.
Yeah, for sure. So I can give a kind of summary for the readers there. So this is work kind of pioneered by an intern I was working with, and supervisor Jacob Khan. So this is Simran Arora, super talented, like a real kind of like really productive, driven person to work with. Really, really great to work with. And yeah, she's very interested in security and personalization and personal data. And we thought about these question answering models, these open domain QA models, as we used to call them. Now we call them retrieval-augmented generators. And yeah, we were thinking about multi-hop stuff and what happens when one database is on device or private, and one is public. And we're kind of constraining it, in our view, to 2 hops. So you have this kind of question that comes along, like you talked about, maybe who is the father of my father is a very simple one. First, you need to know who is my father. And then you find out that the father is X. And then you have to say, who is the father of X? So these 2 hops. And both of them require retrieval over a database. And some of that is private information, some of that's public. And so in that kind of paradigm where you might need to be mixing information from the public sphere, like pinging the internet, versus the private sphere, which is, referencing your private documentation. This is where this kind of thing arises. And we kind of think about what can we do and what can't we do, and to what extent, how well can you build models that are privacy preserving. But what we mean by that is like understanding the risks of, if you say, who is all, let me think about this. Who is the father of our new CEO? Maybe we've just decided who our new CEO is. And so you first ping, like, who is our new CEO? And that's not public information. But then you issue a query to the internet saying, who is Patrick Lewis, just been made CEO? And anyone who happened to be taking a look at what queries we were issuing to the internet could probably use that information to do things with, and would find out some leakage of our private information. And so, like, we were thinking about these hops. So we think that, like, public is safe. It's just public information. You were just asking public stuff. Public private, also safe. Private safe. Nothing is going out. But there is an issue when you first ask stuff on your private database, receive an answer, and then go and ask about public stuff. So there's kind of like, if there is anything other than a private call following a private database call, then you have some private problems. So yeah, we're kind of like interested in defining these sort of this privacy framework, but then we're also interested in saying, okay, like, there's that, offering is kind of trying to understand what we'd now call this, kind of before this became a thing, how lang chains over databases, what the privacy kind of model should look like. But then also saying, okay, we've got an interesting empirical, commercially relevant question, like modeling kind of paradigm to work through, which is, maybe it's really useful to know who the father of our CEO is, or there's more practical things like you could probably come up with, to say, okay, it is really compelling to try and take public information and cross-reference that against private information, and produce models that can be hooked up to several kind of information sources, some of them private, some of them personal, some of them public. And what you can achieve by hooking up these different things and the model hopping over the different ones, routing queries to different databases. And so what we were doing there was building this sort of set of data to kind of study that problem, how well you can navigate that, and how well you can fuse information across these different sources. So yeah, it was kind of like two offerings in that paper.
Yeah, that already just completely expanded my perspective. I hadn't thought about the privacy preserving angle of it. I was just kind of thinking about like searching across multiple indexes. Like if I have one index of books and then one index of like podcasts, and it's like one query for the books, one query for the podcast, and then combining the queries that way. Do you also like that kind of just thinking about like, symbolically structuring your indexes with some kind of high level category and then sort of multi-hop, maybe like that exact example of I search in, papers as well as say like podcasts to try to like combine.
Yeah. I like that. So, I think we consider like, before you used to have some, if you had this end-to-end kind of powerful QA system, you'd have all these modules. They'd look at your query and they'd do some query intent, and then there'd be a semantic parser. And then for the combination of the query intent and the semantic parser, you would maybe route it to one database, you'd execute that query, and then you take those results and you do something else with another model. Now we're kind of looking at the situation like at Cohere, where you'd basically provide the entire schema to the model and hook it up and say, here's what you're working with. Route some queries. Or like route some API calls and figure it out for yourself. And kind of, that kind of thing of saying like, all right, here is the stuff. We can arrange the stuff in, as you say, kind of like ways which are convenient for the LM. And I think that's something we'll maybe pick up on in a minute. It's like figure out the ways which are convenient for an LM to have information structured in a kind of, in a way you say, all right, here is our database of papers, here is our database of this and that, emails, and here are the ways you can query for emails, and they may be different to the way that you'd query for papers, but you kind of show the LM in its input all of those things, and then say, okay, now you're going to route a Weaviate API call to papers with the following fields, or maybe a date range or something. and it can kind of figure out what it should populate. So it's kind of doing all of that work internally for you. So it's doing that query intent, it's doing that routing, and it's doing that semantic parsing all in one go, and producing that and sort of routing that to your different, like to the things that you've got together in this big multi-index, as it were, kind of meta search engine as another kind of term for this. I wanted to quickly pick up on something that I think you're hinting at as well, is how should we structure our multi-index for an LM to use? And I don't have a good answer for that, other than an observation that I see a shift happening maybe commercially, in that for a very long time, we've built APIs for programmers to use, and maybe also, like other kind of computer systems to talk to each other. But we have never been building APIs for large language models to use. And the designs are subtly different, I think. And so there'll be a whole host of offerings, I think, of companies that are kind of designing tools for LLMs, effectively. Say, like, this is an optimal LLM calculator, and so on. Like, what should it's not just sort of what the input signature looks like, so the LLM finds it easy to use and low effort, like doesn't get the parsing, or doesn't produce an unparsable input, but also what the output looks like, how much context to conclude, how much of a stack trace, or other things that would help it do chain of thought reasoning if it was to like read the output of that tool. So I kind of see like a really interesting opportunity there for like, in all sorts of domains, building the tool the LLM wants.
Yeah. I'm a huge fan of like the Gorilla large language model works, which is kind of like you use like self-instruct data prompting to like come up with a natural language command of when you would want to invoke an API, and then you fine tune a language model to pick the right API. And I think with Weaviate, it's really fascinating because that it's like instead of doing the OpenAI function calling approach, where you're going to try to describe the arguments to all the functions in like this dictionary, if you instead have this like just natural language template that describes the tool, and then it can do a natural language command, and then you have this like compressed model that's like a parser in the middle. I see it as like also being more efficient. So maybe if I could quickly get your opinion on that, what do you think about like a 1 billion parameter model that's just specialized on say text to SQL, and then the most powerful model just has a description of the kind of APIs you can use, the kind of queries you can use with SQL, and then sends it to the parser.
No, I think that's also like very compelling. I think often my sense on these things is you've got to work the problem. So it's like, what are you trying to achieve, and what is your cost tolerance, and what is your latency tolerance, and that sort of thing. So like, what's the best system? It's the most powerful model being used in as many ways as possible. From the perspective of like, the quality. What is the best system from something you want to ship or use or experiment with? It's definitely not that. Bringing models down to make them as small as possible, such that they can achieve some part of the wider kind of goal, is really compelling. And so the higher level playbook that I see from a lot of places, which is really compelling, is take the most powerful model that you can get, which is GPT-4, and use it to annotate some in-domain data for you. You've got some supervised data, and then fine-tune it for your task at hand. And then you've got a smaller model, probably a small llama, and it is good. And at no point have you touched a real annotator, which is very, very quick and efficient and easy to kind of dev on. And that's just really compelling. And you can repeat that playbook everywhere you want. I should be, bigging up Cohere's models here. So like, Cohere has some good models.
Yeah, amazing. And yeah, so I fully agree with you on that. I also find that to be really, really exciting. You mentioned another thing that really transitions into one of your papers I really want to get your thoughts on, as well as what are you trying to achieve task-aware retrieval with instructions. I love this kind of like you're searching, like, the Cohere duplicate question data set where you're searching to find another question, not necessarily the answer to the question. So could you kind of tell the story of this task-aware retrieval?
Absolutely. This one's kind of near to my heart. It's funny because like we did the RAG paper, and then I started saying like retrieval has two arguments. There's the query, and then there's the task context. I can't remember what a word I used. I think I used context or something, or instruction, or whatever I was using. And I was saying this quite early on, and I was frustrating my advisor, so Sebastian Riedel. We had some debates about this, and he was kind of like, no, that's kind of like just a redefinition of what the query is, and like relevance is more global than that. Anyway, I was like, there is two things. And I was really interested in that, as he was, and we kind of thought about it and then shelved the idea for ages. And then it's just sort of before instruction following was really a thing. And it turns out that what we were talking about was effectively a really similar thing to an instruction following paradigm, except it was an instruction following retrieval model. The analogy I used to argue about here was like I'd be in a library, for example, and if I was using the computer system to search for what I was looking for, I would use a query. And if I was talking to the librarian, I would say what I was doing, what the information was for that I was retrieving for. I would explain the task context. And then I would say what my query was. And so there's this whole sense of like, you don't just retrieve in a vacuum. You want to retrieve things. Again, these aren't new ideas, but it's kind of like it was a bit zeitgeisty then. Anyway, we didn't do anything for ages and ages and ages, and then Akari Isai came and did an internship with our group, and we kind of were like, hey, this is the time to hit that. And so that was kind of one of the papers that was looking at that and trying to figure out how we should do that. And then like loads of papers came out at once, all kind of doing the same thing. So like thought about this in 2019 or 2020, and then when you do it in 2022, all the papers come out. It was a little bit late, but very compelling concept where you want to basically have more fine-grained control of what you're retrieving. You want to tune your notion of what relevance is in a zero-shot way by explaining it. And that paper was basically about that, saying like, okay, I want to do retrieval, but I'm doing it for the following reasons. And you could define that in instructions. You could also define that as a few short examples of what a relevant example looked like. And that system is very useful. It's a very, very useful thing. And it turns out what we found at the time was dense models really struggled. So a pure dense model at the time couldn't do this well. Re-rankers could do it relatively well. But I'm pretty sure that I don't think we did this, but a large language model that was refining what the query should look like, taking that task instruction, would also do a really good job. And I'm sure plenty of people have demonstrated that since.
Yeah, when I was looking at it, I think the re-ranking thing works quite strong. Again, re-ranking for people listening is you take the query and the candidate document and you apply a high capacity score to it. So if you describe kind of the search intent as well as the query, you can re-rank it really accurately that way. So this kind of language model to reformulate the query, I also find that to be really fascinating. But I'm also curious, like, is there a way to put the intent directly in the embedding or something like that to have?
Yeah, I think so. I'm sure I tend to think of ways to do these things, then I go to the literature and find plenty of examples. You can imagine. So I think what I had wanted to do when I first started talking about this was have a fairly normal dense embedding space for the content, and then a modifier, like kind of extra dimensions that you might concatenate along, that you could hook into for certain kind of intent kind of modifiers. And so maybe you train two models, one that embeds normally and one that embeds a kind of re-ranky style like signal. that would be specifically trying to attack that like long tail relevance. So you say you found your top, depending on the size of your database, your top 200, and actually you now need to map from your top 200 to your top 5, and that extra few dimensions could be the difference. So this kind of why I was thinking about this, and it was a time I was really into in ensembles and dense retrieval models. I have a paper that no one read called Boosted Dense Retriever, that kind of looks at that, and it's not a very practical system, kind of an interesting one, that gets to that kind of notion. So I think you definitely can embed these things into embeddings. I think the difficulty is potentially figuring out what how to embed that is challenging, especially if it's in isolation. So you kind of have this decomposability gap thing that people talk about, maybe with newer multi-vector models, the kind of Colbert style or whatever's come more recently. Probably are much better at this because you might need a bit more of a rich interaction, depending on
Yeah, and I don't know too much about the Colbert. This might be like a dumb version of it, but I can imagine the idea, like a really popular thing with Weaviate is the hybrid search, where you have like BM25 and vector search, and then you do like a rank fusion or a score fusion. And I can imagine having like 8 different phrasings of the query to search, and then some kind of fusion of that also working kind of well.
Yeah, no, for sure. I think so. Just all kind of different variants of relevance being a kind of complex product of like several different models, not complex, but a product of several different models, some of which are kind of doing the good old fashioned term-based relevance, some of which are doing something a little bit more learned and nuanced, and some doing something a bit more kind of instruction following based. I think there's kind of ways to attack all of those things.
Yeah, super cool. So I want to kind of hit you with a couple quick ones, and then an anchoring question, being mindful of time. So another paper, this whole EditEval peer, kind of looking at the editing of text instead of just the generation. I've always found that to be really fascinating. Do you mind giving a quick overview of that?
Yeah, sure. So this is kind of work actually driven by some of my ex-colleagues, I guess, at Facebook. So credit goes to Timo and Jane, who kind of led those 2 papers, I guess, respectively. But yeah, really interesting stuff. So it's kind of based on the observation. It's like humans don't write in the way that large language models do. You ask a large language model to write a blog post, and out will come the stream. There it is, kind of like thing. Humans tend to write in a hierarchical way with a great deal of revision and editing in the middle. And the intent there was to basically say, okay, let's mimic that process of like how humans write. So they'll write something, they'll maybe write the plan, so plan, edit, repeat, peer, you'll find a kind of say, all right, first lay out the structure of a document we're going to run, like maybe the titles or like the rough ideas behind each paragraph, and then you're going to say, go and fill out the first section, and then have a look at how you did and be like, oh, I made a mistake. So go and fix that mistake. And then kind of repeatedly calling this language model to iterate over this document and kind of grow it out. And so Peer was a model that attacked that task, and EditEval is a suite that kind of evaluates that kind of paradigm, and looking at how different models can kind of do that, and how kind of repeated application of maybe a smaller model can reach the individual kind of like one shot or like one forward pass of a bigger model, and kind of interesting trade-offs that you might see there. So how you might do that, and how maybe a language model would be much more effectively applied if it is iteratively kind of drafting a document with you. And yeah, we were kind of working towards a kind of demo of something like a Google Doc where the model would put in edit suggestions at the side, like your kind of editor would, like someone suggesting changes, and the model would suggest changes, and you would kind of together draft this thing. So a model could play the role of the planner, the editor, or the executor, I guess, on the executor of the plan. Or a human could play one of those roles, and you kind of collectively would collaborate to produce this document. But yeah, those ones are kind of I was helping a little bit, but mostly Jane and Timo and Sebastian Riedel, kind of research lead of the group, were the kind of main people driving that.
Yeah, amazing. I thought it was such an exciting paper. And to me, that's kind of like the genius of LangChain, is kind of like coming up with these plans, sort of, where the LLM is like just a compute unit in one part of it. And I love that you mentioned that you could have a specialized model and checking for paraphrases, and maybe that's a 50 million parameter model, or like arbitrarily chosen. I have no idea.
Yeah.
Or like this idea of at one step you come up with like 5 continuations and ask for human input. I know that's one of the LangChain things, and that, yeah, all that's super exciting. So Patrick, I've already learned so much from the podcast. There's so many exciting directions for the future already. But let me ask this question that I always try to like end podcasts with, is like what on the horizon is exciting you the most?
Yeah, that's a great question. So I think I'm interested in language agents, as is a lot of people are, but yeah, effectively kind of an agent, and within it is a language model kind of powering how it works. But effectively, models that have a memory and go out and research things in the world and achieve kind of intellectual effort for people, and kind of I think it's going to unlock very interesting things. So there's dangers here, aware of those, need to mitigate those, but kind of automated researchers, giving people the ability to kind of do clear-headed analysis, research, understand things, build kind of grounded attributable kind of documents through the kind of process of research, which involves kind of formulating hypotheses, going out, acquiring evidence, reformulating a hypothesis, and at some point saying, I have done my research, I'm going to write up agents that can kind of mimic that process, is the kind of thing that I'm excited about for the next maybe year or two.
Yeah, well, we also love that idea, and we're calling it generative feedback loops, to describe like the generative model feeding data back into the database, and this kind of loop. And so I'm curious, do you like that term? And if so, could you please write another viral paper?
It's funny. It's quite similar to one of the ways I described this before we kind of started to work on it. It was an autoregressive research loop. So it's almost the same. Yeah, no, it's good. And I like the idea of a model. I guess this is a slight tangent. Managing its own context window, which is effectively part of this process. So you say like it has a memory, it can write to it, it can take things out. And if its memory maps to its context window, you can kind of think of it as a model that kind of looks after its own context and kind of has a working memory that it's in charge of, which I think is also a really fascinating concept. But yeah, like certainly models that write to a database and kind of build up this more long-term memory is really cool, for sure. Like kind of taking notes as it goes. Fascinating stuff.
Yeah, I've been fascinated in that like in that MemGPT paper, where it's about like what do I add to. I've done like a search, and now it's like, what do I add to my working context, as well as trying to blend that. What do I write to my long-term context? So trying to get that right has been amazing. Yeah,
these are really, really great.
Yeah. Patrick, thank you so much for joining the podcast. I can't tell you how much, your Retrieval-Augmented Generation paper back in 2019, I was still in school, and watching it just like profoundly changed my understanding of deep learning. It's such an honor to have you on our podcast. Thank you so much.
Thank you. It was great to be here.